Alright, welcome to Chapter 1, Tutorial 9, Memory Management. We're going to be brief here. I don't want to get into details. I'm going to talk about very basic memory management, how to create something and how to release it in C++. And I'm going to talk briefly about more advanced ways of doing memory management, which will basically be more like the Java or the C# ways, where you can just set a pointer to null and then it's going to release itself without being garbage collected. But there is a way to do this in C++. In C++, it's a little bit messy to do it this way. Anyway, you will see. Let's erase all this. We don't need this. All right, so let's start. Remember, we had a hero pointer. So by default, you can initialize it to null. All right. So little difference here with C# and C++. You don't write just null like that. Sorry, C# and Java. You don't write just null like this. You need to write null ptr, right? It's a null pointer. All right. So if I see out this just for fun, key hero equal. Right, so this should output 0, 0, 0, 0, 0. Right, it's a null pointer. Previously, this is C++11 syntax. Previously, you had to basically type null in capital letters like that, and this is basically just a define. So move the cat. Thank you. So this is just a define to 0 basically. So this is a macro. I'm not going to talk about them, but before you were just setting things to 0. It's the same thing as setting them to 0. Right, so, but I want you to use null ptr for everything you do pointer related, because this has some kind of type checks also. I can do a equals 0 and it will compile fine, but if I do null ptr, it's going to throw me an error, and you kind of want that restriction when you're programming. Anyway, so that was the basic of initializing a pointer. Oh, and I should mention that everything in C++ is not initialized by default, right? So if I don't initialize this, well, it's actually throwing me an error. That is new. That is new. It's probably my error levels in my settings, but not all compilers will throw you an errors. Most of the time it will work, but the content of the address will just be like random values. It will just be, yeah, garbage stuff. So you don't want to actually use it because you would crash. The reason it's like that is because you don't always have to initialize something, right? Sometimes you don't want to, and this is, there's an affectation being done there, and you probably waste an extra CPU cycle. So C++ is all about speed and such. So that's why it's like this. All right, so now I want to create a new hero on it. Right, this is just, I have a random pointer and I want to create a new instance of it. So what I do is I do, just like C# or Java, I do new hero. And the parentheses are basically for the constructor, so Bob. And that's it, I created a new hero. Now if I print this, it shall have an address, right? So what the new will do, it will allocate the memory for it. And that's it. So this is none different than C# or Java. The difference is you have to delete it manually. So if I do phero equal null ptr, well, you're not going to see it but it's leaking here, right? That hero memory is used and you can't reclaim it anymore. So you're literally leaking here. And there are some tools that you can use. It's a little bit more complicated, but you can debug this thing and find out what's leaking in your program. But just remember to delete things when you're done with it. All right, so let's print our hero here. All right, and when you're done with it, you have to call delete on it, just like that. All right. So now if I call print on it, it will crash. It will crash because, So let's go on the stack here. Into a crash because the row basically got deleted, and you still try to do stuff on it because it's still old an address. So you see after delete, oh sorry, let's remove the line that is broken. Okay. You see the address is still actually stored in it. Right? You know, delete will not set it back to null. So, but the address points on invalid part of the memory that your program doesn't own anymore. And what's even worse is if you don't set it to null, let's say, after, is you can have something else somewhere that's actually allocating an row again, and the program will decide to put it in the same memory location, but it's now not the same error, the same class, but your function, you know, might still work because you actually own that memory, and then stuff are going to start being very wacky in your program. So you have to be really careful in C++. That's what you have to know. And so here, if I set it to null, this should also crash. Boom. All right. So you can see that this, I'm inside 0, this is actually null. So that is wrong. All right. Oh, let's see quickly something here about this. This is a pointer. All right. So you'll see in C#, sometimes people will do this, right, to access the variables when you're inside. So you can know this is part of this class. Sometimes people like to do this. In C++, you'll have to do that little arrow thing because this is a pointer. As you can see, it's a arrow star. All right, little parenthesis here. All right, so that's for basic memory management. You knew stuff and you delete them. All right, so not too complicated, but you see that you have to be careful for everything you're doing. You have to remember to delete stuff all the time. Yeah, we'll see Destructor later for class. So you add a constructor there. There's also well, let's just see it right away. There, when you start with a little tilde like this is a Destructor. So this is going to be called. So this is called when your row gets constructed, and this is called when your row gets deleted. Now you can say died. Okay, whatever. All right, so Bob died. I think has died. Yeah, whatever. My English. So basically, when you know, when this happened, I can see out something else. This is after the delete. Okay, so you can see that Bob has died on the delete call. So delete will call the destructor because your row might have allocated memory also that you want to deallocate it in destructor. So this is very useful. It's something sometimes I want in a program like C# or Java, and you kind of have to create your own disposal functions in C#, and this is annoying because when you're dealing with unmanaged memory like in XNA with textures and stuff, you have to release them and you're going to leak, so you kind of have to call those functions manually in C# and it gets annoying. So this is very good. This is very cool features of C++ where it will call a destructor when it gets deleted. I like this. All right, so that's it for this part. Let's put that together. All right, so I will ask you to never do this for now because you might have it's not very safe, as you can see. If you feel hardcore, just do it this way. But we're going to show you a more managed way, let's say. So it's not managed, but it will feel like it's managed. All right. Yeah, so let's call a function for this because I want to explain the scope a little bit. Let's call foo and define a new function here. Foo. All right, so we're going to do our next stuff in there. So there's a way to create a pointer that when you set it to null, or you never have to delete it. When you set it to null, or when the you leave the function. Let's say I do the same thing I was doing here. Right, so let's say I was creating a new Bob, and then do some things like print it and then quit the function. Let's call it a different name so we can understand. So you'll see that Dave never died. It's a leak. It's leaking. Why? Because it got allocated and it never got deleted. You know, I would have had to do this. So there's a way of doing this a little bit more, so you don't have to think about deleting it. And for this, we're going to include standard memory, this, and it's called a share pointer. All right, so what you can do is auto Dave, right, equal and make shared, and just you know, remember, like the vector or the list, you have to specify which type it's going to be, and then you just initialize it, Dave. All right, so this is now a more complex type. It's a shared PTR of hero. But you know, you can do the same thing. You can print it like this. Okay, you have a similar syntax, and the beauty of this is when it goes out of scope at the end of the function, it got destructed there, right? So you kind of create a smarter wrapper around it. And yeah, so I kind of want you to try to use this as much as possible. In the gaming industry, we do not use things like this. It adds a little bit, well, not a little bit, it's actually pretty big overhead on top of it, which means there's more CPU cycle being wasted of doing some checks and stuff, and it creates a class, and it puts the hero into the class, and there's a bunch of stuff happening in the background. So in the industry, we always we're fighting for like better and better FP frame rates and stuff. So we usually don't do things like this. We try to manage memory differently, and we will use raw pointers on mostly everything. But you know, this is still going to be faster as your average C# or Java program. So you can start by doing this until you're more comfortable with C++. You will avoid a lot of mistakes, and it will be good. So that's the first way of doing it. As you can see, really simple. It gets out of scope. It gets deleted automatically. So that's wonderful. Also, so let's say this after the delete. So this is not going to be after the delete, all right? Because it gets destructed when it leaves the function. But if you want to destruct it before, you can set it to null, just like you will do in C# or Java. When you're done with something, you set it to null, and it will destruct it. And see, Dave has died before the text has printed, because you've set it to null. So if you want something, if you're more comfortable with how it worked in C# or Java, well, you can use it this way. It will make your life a little bit easier. So that's why I call it manage, but you know, it's not garbage collected. What's happening in C# is it's not being destructed right now. It's going to eventually getting picked up by the garbage collector, and this, you know, this will kind of stall your program because it might delete a bunch of them at the same time. Here, it's going to delete it right away, right? It's going to destroy it there. All right, so okay, that was for shared. You can also return it, right? So let's return this. Shared PTR, that's how you write it. And we're going to return it. All right. Shared Dave. Then you can print it. Right, so you can see, you know, I got return from it, and I can still print it. So it lived on, and whenever you set it to something else, so let's say auto shared Dave 2 equal this guy, and then I decide to delete this guy. Well, the object will still be alive. As you can see, if I showed it, there's no die there. The die actually here happens after this. So don't worry if you don't see it. Because now there's still another instance that hold it. So this is wonderful because you might have multiple class holding a pointer in your hero. And if you just nullify one, you don't want the other one to basically die. There's sometimes you want this to happen. We call that, it's different, we call that weak pointers. We're going to see that in the future when we actually work on a game. But so yeah, so it's just like C# again. You can you can add the reference to it for any other kind of pointers, and so yeah, you'll notice I use auto here for those things because the type is actually a little bit longer, so it's annoying to type. Right, so that's it for this tutorial. You have the raw way of doing it. You do a new and you do delete, and you have the shared way of doing it, shared pointer, which is more like the C# Java way of doing it. All right, so hope you understood this. That will be all for basics tutorials. I think you know enough to actually jump into graphics now. And so yeah, so see you into chapter 2, and hope you enjoyed it too so far.